In this example, I am going to show you how to use input subroutines or input tasks, how you call it. So let's make a new project. I'm going to use, for this example, SE, series PLC. Okay, so now I have a new project. What I'm going to do, I'm going to create input task or subroutine, how you call it, and I'm going to use a global variable table. I can use the main table, but for the last year I'm creating new tables for different variables. So but you must be sure the global variable table has different name than program. For example, now it's input and here input. Once I will press OK, I will get an error. So I am going to make inputs and I have input global variable table. So let's make one variable. For example, it will be safety input. It doesn't matter now. And what I'm going to do, I'm going to export this global variable table to, let's select desktop and let's make global symbols, just example. Let's open the file. Be sure you have the correct Unicode. This one is selected on my computer. And here we have what we have created. Let's delete this part for a while and let's let's imagine we have 7 inputs. The first input is safety, another input, let's say we have reset button, start button, stop button, and let's make stop button is normally close contact. For example, motor 1 ready, another motor ready, and let's add some sensor. For example, this one sensor is for the first motor and another sensor is for another motor. So now what I'm going to do, I will copy it, paste it. I have empty line here. I need I need to delete it, but I will delete it later. So now let's select this one, and what I'm going to do, I will use find and replace function, Ctrl H, and what I'm going to do, I'm going to replace this symbol. This is my physical input symbol, tag I and strich, and I'm going to replace it with X. So replace. So now this is my physical input, and here I would like to have my local memory bits. So for example, I'm going to replace X with M. Depends on PLC you are using. It is possible your addresses will be like this, for example, right? So once you will copy, you will get this like this. So you can, there is no M memory area like this, so you can also use drag and drop function. And let's go back to our inputs. So the point is to create local memory bits. What addresses is here, it's not important for me what I'm going to use, but I'm going to use the same address like X and M for this type of PLC. So now let's delete the empty line, because the other way we will get an error. and let's save it. Now import global symbols, be sure it's selected correctly, and I'm going to clear the table before importing, like this. Now open the input subroutine, and what I'm going to do, I will place this, and I have 8 inputs on this project, on this example, so make 8 lines, and this type, for example, this address must be equal to this address. Here we have x1, but I know I have m1 under, and x2, m2, x3, m3. By the way, I'm using the tab button. I will show the difference, which has been x4, let's press enter, m4, let's press enter, let's press enter, enter, enter. You can see it stays in the same network, but if I'm going to use tab, it will be much more faster. Let's make tab, 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 tab. So this is what we see now here. You can switch between address or symbols. You can see X, M, X, M, X, M. If this button doesn't work for you, go to Tools, Options, Symbol Table, and check this one is selected. So select it and press OK. So now, as you remember, for stop button we have normally close contact, but in my program I would like to see it as normally open. So what I'm going to do, I will make inversion here. So let's make it like this. Now the signal is inverted. So that means when the button is not pressed, I don't have signal here. When it's pressed, I have signal here. Another point, I often periodically use reset button with off delay function. So we can go to our variable table, or I can edit it here. So let's make another variable, for example m8, and off delay, save it and import it. As you can see, reset off delay bit has been added. So let's go to our subroutine. What I'm going to do, I'm going to use like this, and for example we can make it in different ways. I will make it in 2 different ways. I will show you how it works. So now when the button is pressed, I have signal here, and I set this signal, and when it's not pressed we are going to use the timer, for example T0 with 2 seconds, for example, and what we need to do is reset this one by this timer. I like to have the timer on the top, so I will cut it and paste it on the top. Okay, so when the button reset is not pressed, the timer is activated, and after 2 seconds it resets this signal. In my program I'm not going to use these signals, I'm going to use signals with X. Okay, just for example, on the start button, we also would like to have some on delay function. So let's use another timer. By the way, you can use function block. It is here, but function block use much more memory. So I'm not going to use function blocks. I will use timers. It's up to you how you organize your program. I'm just showing you the example and the benefits of input subroutine. So let's say we want to have 2 seconds on delay, and as I told you, I like the timer on the top to have T1, and for example let's write on delay 2 seconds. Normally close input, and for example for the sensors I would like to have an option to select in my HMI, or it's normally open or it's normally closed, because just for example I have used normally closed sensor, but the sensor has been failed and you don't have the correct sensor to replace it. You only have normally open, but what you need is normally close. So if you replace normally close with normally open, you will need to change everything in your program. So what I'm going to do, I'm going to add an option in my HMI to select what type of sensor it is. So to do this, I need to check my retentive range, and you can see in my M memory area it starts with this address and ends with this address, and on block another block we have another. So let's take, for example, I'm going to use M600, and for this let's make, for example, new table, set NC, addresses, and let's give it a name, set NC, and we can add, for example, sensor name, or just write like this, or we can write command here, just make it in this way. We can export it to global variable table, but to Excel file. Okay, we can make it by Excel now, but be sure you are not importing. Okay, this will be to S1. So now we have set NC1 at set NC2, different addresses, save it and import. Okay, go back to our inputs. Now let's create a function for it. It's very simple. What we need to do, just make like this and make this normally close, and the same here. So now copy this one here, copy this one here, and here will be set NC1, NC1, and here set NC2 and set NC2. Okay, let's try to compile. Open my ComGR settings. Let's check what we have here. I have simulator, DVP simulator, device name, SC, and we must be sure the state is start. Now we have stop, so let's press start. We can close it now. Tools, communication settings, simulator is selected, and download it. Let's close the window when it's done. Okay, go online. Now the PLC is in stop mode. Let's run it. And now what I'm going to do, I would like to simulate my physical input. Once I set it on, I will get an error. But there is a function here. Pay attention, it's high risk to use this button, this one, on your real project. Now I'm using simulator, so it's safe to use it. But if you have a real PLC and you have real mechanics, so use this button only when it's really necessary, because what it is going to do, it will hold the current state of the physical input. So now it's in simulator, set it on, and now I can simulate my inputs. You can see. So safety is working directly. Let's see how reset button works. See, both signals are on. Now I will switch it off, release the button, and this one goes off immediately, and this one with 2 seconds on delay. Repeat it one more time. See, this is the difference between direct and with off delay. For the start button, we have 2 seconds on delay. Let's see how it works. See, and set it off, and it goes off immediately. Stop button is normally close contact, so when it's not pressed, we have signal here. So let's set it on. We have signal here. The button is not pressed. What we see here, the button is not pressed. Set it off, the button is pressed, and we see the real state, or it's pressed or it's not pressed here. For the sensors, let's take, for example, I would like to have this normally open and this one normally closed. So in our HMI window, we must have an option to select this bit. So let's say it is normally closed, and now you can see I don't have signal from this sensor and I don't have signal from this sensor. So, and the state is different. Once this signal, this was on, this is on, and when this, I get signal here, I don't have signal here, because it's normally closed. And let's try to add off delay function timer for this signal, for example. So I will go to edit mode, online edit, and let's add a timer here. For example, let's use timer 2. Let's place it on the top. Oh, no. Okay. Like this. And for example, I would like to have 2 seconds. After this 2 seconds, timer 2. So this must be set, and here must be reset, but we need to make an inversion here, so we can use this function and make it like this. For example, like this for the timer, and download it. Let's see how it works. So now let's say on, the sensor is on, off, and we have 2 seconds delay. What just happened? T2 is on. Why it's not resetting it? T2. Maybe it is blinking. Okay, so it's possible it is blinking in this state. Now PLC. Because the inversion has been here. Okay, let's make it like this. And here is T2. This structure should be better. Test it one more time. Set it on, it's on, set it off, and 2 seconds goes, and it goes off. One more time, set it on, set it off. Okay, so this is the different. If we will use normally close, let's see how it works. Now it should be on, but when we have signal here, it must go off after 2 seconds, like this. So, as I told you before, here is the different. We can use like this, or we can write the same like this. Just cut, paste. What the hell, it's not working. Cut. Delete, delete, delete. Okay, let's test it again. It must work the same like before, but another structure. Both are on, off, and this must have 2 seconds delay. So later in my program, I'm not going to use these input signals. I'm going to use these input signals. So okay, let's go offline, make a new program, for example, and in this program let's make some set, reset. I'm not going to use any variable. Let's make this will be, for example, X start, and here X stop. So when I will press start button, this will go on. When I will press stop button, this will go off. Another very important thing with task priority, so be sure your input subroutine here in the task list is on the top, because what we need to do first is to read these input values and to organize them, and only then we will use them in the program. So be sure it's on the top. You can use drag and drop function to arrange it, or just double click here and go with arrows here, top or bottom. So make sure it's on the top. Let's download it again to our PLC. Go online. Let's make 2 windows here, and now, as you remember, our let's make it smaller. Okay, now I'm going to press start button, and after only 2 seconds it sets this. And if I will press stop button, it's normally close, but here it's normally open as used, because for me it's much more easier to understand. In the other way we will need to use here with normally close contact this point, but I have made inversion here, so let's set it off, and imagine the button has been pressed and we reset this. So set this off, set this on. So this is a good example how to use input subroutine. We can use direct signals, we can use with off delay function, on delay function. We can also add an option to select, or it's normally closed or it's normally open, to select it from our HMI, and we can make inversion directly without selecting what it is. So it's up to you how to use it, but the benefits of input subroutine are really good.